Good evening, everyone. So let's begin with our presentation
Hello,
session.
ma'am. Good evening.
Yes, Kanchana. Are you ready with your presentation?
Yeah, ma'am.
Yeah, okay. So you can start
Let
your
me
presentation.
just give me a minute. Let me rejoin.
Okay, okay. Kanchana, what happened? Are you ready?
Hello, ma'am.
Yeah, you can start.
Shall I start my
Yeah.
presentation? So, a very good evening, ma'am. My name is Kanchana Ganga Daita. I have completed my graduation in 2023 at University College of Engineering, JNT, Karnataka. I have been doing the internship in the embedded systems and IoT domain, and this is my task number 7. And the topic I have given was configuring and connecting Arduino to networks and devices. So firstly, the contents of my project were introduction, what is the significance, what are the devices required, explanations about those, and what is the working principle behind it, and what are the advantages of the devices used in our project, and how we configure those devices and how the connections are happening with Arduino. Also about communication protocols, and finally we end with the conclusion and principles. So actually, we all know that internet is the main thing which we are why we are all surviving by using all these technologies. So it covers almost all the spheres of life. Like it progresses our work. Also, it enables us to uh, do any of our work. It makes all our work easy. It can link communications. Also, it can provide us different options for configuring and connecting different devices using data. So in using this internet, and also as we have so many internet devices such as Wi-Fi, Ethernet, or some other devices which provide us internet, which are the devices we can use to access the internet. So what is the significance of our project means? See, if we have like any intermediate to advanced level Arduino project, if we have any basic Arduino project, in that Arduino project, what we need to do is for logging the data and for getting the data, also to make the data to make the software enable easily. If we have any Wi-Fi connections or any Ethernet connections like Modbus or any other protocol connections enabled into the Arduino itself, means it will be so easy for us to make any of the projects. It will be also helpful for the researchers who are doing projects in these domains. So we can recommend it to the users with poor internet connections or even no internet connections, such as in remote areas too. Because if the device only itself is having a Wi-Fi connection, by having the connections made it on itself means it will be used anywhere, it can be carried anywhere, it can be portable. Also, it resolves so many real-time commands which we can use in our day-to-day basis. So this software IDE can help us to recover all our problems. For example, data network issues or any other data problems. So let's suppose that a person is doing a project. For example, in that project, if he might face any of the issues like network issue or Bluetooth issue or any maybe wireless connections or wired connections, whatever it may be. So in that case, if Arduino itself is enabled with a controller, in which the control is maintained by using some microcontrollers or any GSM, etc. Uh, so that it can be happen like by sending messages, sending emails, or receiving any data, along with having the uninterrupted connection. We can have all those things by just making these kind of circuits. So let's dive into the project even more to get even more clarity. So first, what are the devices we use to connect the Arduino in this project are Wi-Fi, GSM, Ethernet, and Modbus. Let's see what are those. Wi-Fi means we all know Wi-Fi stands for wireless connectivity, in which it is a wireless networking technology. We all know that Wi-Fi is commonly used everywhere in the schools, offices, households, like even in coffee shops, hotels, etc. So like this is a transmission network which allow us to access the internet. So the second thing is GSM. GSM means Global System for Mobile Communications. Actually, it is developed by the European Telecommunication Department. It is now called as Schneider. Also, it is developed after getting the second generation of digital network. So while we are having 2G, we started it because only after getting the second generation network, like only after getting the 2G network, what we have done is they have thought about the sending and receiving the messages. After getting 2G mobiles, we started getting like how to send messages, how to receive messages, even in the text format or any like the basic text format also we don't used to have all those things in the first generation mobile. So in the second generation mobile phones and tablet, like by the starting of second generation, they have discovered all these type of protocols and all. By using this, we can just send a text message, send or receive text messages. And third thing is Ethernet. Ethernet is a very traditional model technology. It is so far behind the Wi-Fi connections if we observe. Also, we can see LAN, WAN, or CAN networks in our like day-to-day life, in which it is a wired connection. When it comes to Wi-Fi, it is a wireless connection. So this is the basic difference between Ethernet and Wi-Fi. And one more thing is it needs to have a connection. So it needs to connect between the devices. Even if there are one or two devices we are connecting, for example, the LAN has to be connected to a circuit, like by using any plug boards or switchboard. It has to be connected to the router. Also, the other end of the wire should be connected to a laptop. So there is a difference between the Wi-Fi and this. For example, if we take Wi-Fi, we don't have to connect any other wires to the devices we are using. We can use it's like a portable way. You can use for laptops, like for televisions, mobile phones, etc., without any connections of wires. So in that case, it can be the we can say Wi-Fi is the even more used technology. Like it is the upgraded technology, but Ethernet is the traditional model. Even that to have some applications we'll get to see later. And Modbus is used to transmit the signals, and it is a system like which if there is a system and there are some controllers connected to a system, it just transfers the data from one device to another device which are connected in the same system. For example, we can take home automation systems. We use a lot of sensors, controllers in the home automation systems. Or else, suppose indicators such as for water tank fillers or any like air quality systems, air quality monitoring systems, for example, air pollution checkers. For any of those kind of devices, will actually connect a lot of sensors, will actually connect a lot of devices or any controllers such as 8051, Arduino, UNO, etc. So in those connections, or what we need is we need to send the data for each and every component to ensure there is there is an uninterrupted power supply, uninterrupted data to provide it to all of those devices, in which we can have an assurance like if we have the Modbus connected, it will just supply the uh, data to transmit and receive the signals for every of the device which it is connected. And one more thing is it measures temperature, humidity. Also, for communicating results, some sensors measure temperature, humidity like DME sensor or some other sensors. To measure that, it needs to have a data connection. It needs to have an uninterrupted power supply. So for that kind of applications also, we can recommend this Modbus as an important application. Next, what are the versions of are we using? Here we are using ESP8266 or ESP32 uh, for the Wi-Fi processor. We get to see more about it, like more specifications about it in the later slides. And the GSM is Global System for Mobile Communications, in which we can use SIM 900 or SIM 800. We have used 900 in our project. And Ethernet means it has a different kind of modules. We have used Ethernet Shield or Ethernet Shield 2. You can use any of those modules. And Modbus also having different kinds of versions. RTU and IP are most popularly used or most commonly used versions, you can tell. And there are some protocols. See, after these are all the network protocols. As we have seen, these are all the network protocols like Wi-Fi, Ethernet, Modbus, or these GSM. These are all the network protocols in which use we need to transmit the network or to receive the network. We use these protocols. But what is the communication between that? If we want to transmit the data or we want to receive the data, that can be done by using a Wi-Fi or any Modbus like that. But how the network knows that we want some data? So we need to communicate with that device. So, for example, if we take a laptop, we need to ask something to the browser by using laptop. Like in the laptop, we are using we are browsing something and we want some data. So if we really need some data, how to communicate with the website, like how to communicate with the browser that we want a particular data. So those are some important protocols in which we can communicate directly to the browser. It will just filter what are our expectations and it will provide us results. Such kind of protocols are HTTP, MQTT, TCP, and UDP. So we'll get to see the more about these network protocols and communication protocols. So let me share the document for this one. Yeah. So the first networking protocol, the most protocol is Wi-Fi. As we have already know, it is a family of wireless protocols because wireless doesn't need any wires connected to transfer to send the data. So it doesn't require any wire connections. Of course, it will be connected to of course, the router is connected to the pole in which the main transmission network is provided. And to that, we need to connect to uh, an area in which it is getting an uninterrupted power supply. Those two are important things we need to take in mind in order to make the Wi-Fi connection secure. After that, if you just connect with your mobile or laptop or any desktop or any other thing, it doesn't need any connections like other. Coming to Wi-Fi, here we can use LAN, internet access, etc. Also, we can like how the Wi-Fi is transmitting the network. How it is transmitting the data is biggest question. See, we are all using Wi-Fi in many places like schools, offices, houses, or any other, even parks or railway stations. Even in these days, as the technology is upgrading, Wi-Fi is available in every area we go. So it will exchange the data by using radio waves. So it is the most commonly used computer network in which we can use it even locally or globally. We can it has an applications in even local level or global level. So coming to the users, it has citywide applications. We know that it has been expanded to all the cities. And one more important thing is India was the first city to have the Wi-Fi enabled city. Like it has become the very first city to become a Wi-Fi enabled city. Also, a company has Wi-Fi net in Mysore has a lot of hotspots in the neighbor villages also. So that in the remote areas or any areas which are having poor internet connections can also have upgraded version of internet versions, upgraded level of internet versions, so that they also can have uninterrupted internet supplies. And one more thing is geolocation. See, if the GPS is not available, like due to any network issues or something. By using Wi-Fi positioning and by using the Wi-Fi hotspot location, we can identify where the person is. And one more thing is motion detection. So how it is done by using like Wi-Fi sensing in some by using some applications, we can use motion detection or gesture recognition by using this Wi-Fi as an application. So second thing is how the Wi-Fi operates. See, we all know that how Wi-Fi, like we all use Wi-Fi, we all know the what are applications of Wi-Fi, where it will be used, how we should connect the Wi-Fi by using many, like how we secure Wi-Fi to protect the third person from using it. We all know all these things. We all experience all these things in our day-to-day life. But what if it comes to the technical part of Wi-Fi? Like how does it actually work in a technical manner in order to provide data to the receiver? So firstly, what we do is we need to make a connection between the router and the device we are using. So that is the important connection. So also the connection which we made is also to the router only, not Wi-Fi. Actually, what is the Wi-Fi the Wi-Fi provides that connection of transmission between the device we are using and to the router. So it actually it uses the radio waves to transmit the information between the device and router via frequencies. So what are the frequencies? It uses two radio frequencies. One is 2.4 gigahertz and another one is 5 gigahertz, in which those two frequencies are also again splitted in order to avoid the high trafficking or any interference of third devices or any communication lines in between. So for avoiding all those interferences, these Wi-Fi will be shared into the multiple lines. So when it comes to the sharing, what happens is if if those two frequencies are creating multiple channels, if we are using up to some of the data, it will use some frequency. Or if we are using even more data, for example, we are using laptop, two mobile phones at a time, it will increase its frequency because it has to be done at a very less time, right? So how long like how much the frequency is increased, that much time will be decreased. We all know the frequency is inversely proportional to time. So if the frequency is so much increased, means automatically time will be decreased, so that our connection will be even more faster. Our connection will build even more faster. So the first step is actually the user requests the data, requests the router to accept the data transmitting process. So how we accept means it is embedded into the device only. So actually when we tap on the required device we need to connect, what happens is the code which is already written by the developers will be converted into the binary language, because router is also a computer system. It will also understand, like our devices are also computer systems, right? Even our mobile phones, laptops, they're all computer systems. They don't know our language, so that they convert our language, our heavy like human interpreted language into the machine language, like binary language. So those that will be converted into zeros and ones. So after those conversions, what will happen is these radio waves, like what are the radio waves will be converted into, the radio waves will be giving some frequencies in which Wi-Fi is using. So after whenever we click on the Wi-Fi device we need, it will convert our data into code, and router receives this data through the radio waves. That router will convert this again into the zeros and ones. So at that point, that system identifies, okay, this person is requiring some data. So that will be the data will be transmitted to our device directly. So these are all done in the radio waves format. So we can't even we don't know how fast it works. Like it will be working at 50 Mbps. We can see here 54 Mbps. So it is totally unbelievable that 54 million ones and zeros are getting transmitted into the binary data in a single second. So that in that fast manner, we are getting our data into our mobiles or laptops automatically when we are tapping on the Wi-Fi device. So in this way, the Wi-Fi will be worked. So firstly, a user will be requested the requesting command for the device to accept the data. It will be converted into zeros and ones. Again, the router receives that code. That code also be received into the receiver zeros and ones will be converted into the router understandable language. After that, data will be accepted. So what does Wi-Fi does mean? It just transmits the radio form, the radio waves. The transmission of data will be done in the radio waves. And what are the modes of operation? See, Wi-Fi have different modes of operation. So first thing is infrastructure mode. Infrastructure mode means it is the most common mode. It is the like very usual mode that we use. So one of the things is it simplifies the protocols because it doesn't have any heavy architecture or any compact or any complex devices included in that, so that it can be used normally. Here it is the Wi-Fi. So it is can be connected to a laptop or a desktop or any other devices we want. So it can be very normal, like very usual connection. Like what are the mode we are using, like in any households or any like simple domestic applications can be the examples for this infrastructure mode. And second one is ad hoc Wi-Fi, ad hoc and Wi-Fi direct. So ad hoc and Wi-Fi means it will just connect our data like to from one device to another device without any access point. See, if we need to have an intermediary, we can say it has like bus topology, right? So if we don't have any intermediary option, we can call it ad hoc. So if we have two devices, for example, one device is already getting internet from the main source. It can directly provide data to the another device which needs internet without having any connection or any intermediate third party device from the main source giving providing internet. Here we can see, so from the LAN network, the host computer is getting the data. It can provide data to the any number of guest computers up to its limit. So it can be in that. So it can be used where the systems are more and the data should be transmitted in the even more data should be transmitted expanded to the even more locations. Means it can be so useful because getting data from the single network and we have sharing with every other device we want, it will promote the specification of Wi-Fi direct, like direct file transfers or media sharing through security methodologies, etc. So we can also enable two, three devices on the same Wi-Fi network. They can also communicate directly. So if we have one host computer, it will just connect to the other guest computers automatically without the acceptance of this internet like main source provider, for example LAN or etc. This is the second method. And coming to multiple access points. So multiple access points means we have the single we have the single router as always, but the access points will be different. So there can be two, three access points in the single that are provided for the single router. So if there is a single router and there are different access points, we can access it from the any of the locations we want. For example, if two, three persons are working on their laptops, all of them are working on some heavy technologies which require a fast speed of internet. So what they want to do is they can go for different access points and they can browse whatever they want. Because if they sit at the same access point, if they get any network issues, it wouldn't be that feasible for them. So if such kind of applications are done, they can use even more, even more faster and even more advanced methodologies can be applied. So these are the three modes of operation of our Wi-Fi. Okay, so what we have seen is how Wi-Fi networks work in usual. So now what we need to say is what is the connection or configuration that has to be needed for the Arduino UNO and the Wi-Fi processor we are using. Am I visible, ma'am?
Actually, you're visible, but a little voice is breaking.
Oh,
Yeah, now I guess it's fine.
is it okay now, ma'am?
Yeah, now
Yeah,
it's fine.
thank you, ma'am. So let's go with configuring Wi-Fi connectivity. So actually, how to connect that Arduino and our Wi-Fi processor in order to have this both into one configuration. So firstly, the Arduino we have taken is the version of 80 megap, 80 mega 3280, or basic respect. And the Wi-Fi processor we have used is ESP8266. So we can have any of the processors, and one of the main processor or one of the most commonly used processors are the ESP8266 Wi-Fi module integrated datasheet. It has 14 digital like input output pins and 6 are analog pins. So in which what we can do is the Wi-Fi connections and those Arduino connections are to be merged, in which both connections will have the like each of them will have the configuration with each kind of pin. For example, if we have those 14 input output digital pins and 6 analog pins, we can give 5 volts input pin to the 0 receiver pin and transmission pin to the digital board of the Arduino. Similarly, 5 volt like 0 volt ground pin of the Wi-Fi processor should be given to the 0 volt Arduino board. So same pins, 5 volt pin is connected to the Wi-Fi processor input pin and ground pin is connected to the ground pin of the Arduino pin. So both the pins are connected. So the configuration will be happened. And whenever we provide a code, it will just configuration, like the configuration just happens along with the connections. And while we connect these RX and TX of the Arduino to the LED, which is connected to the processor of the like 8051, we can connect it to the RX and TX pins. So automatically we can use like 8051 or ESP8266, whatever it may be. That can be connected directly to this Arduino board in RX and TX pins, 0 volts and 5 volts pins, which are connected to the ground, and 5 volt is connected to the VIN pin. So all these pins are connected and configured. We can see here it will be 80 mega 28 provides UART. So it will provide 5 volt serial communication, and that is available same in the analog and digital ways like 0 and 1. Also, Arduino includes a serial software monitor. So whenever we provide a code, the serial software will work. So what is the Wi-Fi processor we are using? We are using ESP8266 processor, and the operating voltage would be 3.3 volts. The flash memory processor will be holding is 4 MB, and it has 8 MB instruction and 12 MB data in the RAM, and its clock speed is 80 megahertz. So now let's go with the code. Also, it has a wake up time of less than 2 milliseconds, and the frequency we have already discussed. The frequency can be 2.4 gigahertz or 5 gigahertz. So in this the application, we can use 2.4 gigahertz. So what is the code we have here is we need to include some libraries such as y.h and UNO Wi-Fi because UNO is the Arduino code we have already using your Arduino UNO R3 or any 80 mega 32. We have to use the we have to include the libraries. Also, these are the basic lines of code which we need to give for any Arduino board because what is the output pin, what is the digital write pin, what is the digital read pin. So 13 output and 13 low is digital write and read pins. Also, when the character is present, it will just ESP serial and serial are the two modes of operating here. So when it is ESP serial mode, it will just write what is the data present in that. And if it is in mode, if it is present in character, it will write what is present in the different second mode. So in this way, after getting the code, it will configure itself and it will just continue to operate. Second thing is GSM. GSM means the Global System for Mobile Communications. As we have already seen, after the starting of 2G mobiles, they have introduced this kind of mobile communication. For example, you can
Kanchana?
or give message data,
Kanchana?
etc. So actually, this GSM operates on the combination of both TDMA and FDMA. TDMA stands for time domain, time division multiple access, and FDMA stands for frequency device multiple access. So it has a full duplex technology so that we can even send the messages and receive the messages. If it is having half duplex means we can only receive the messages or else we can only send the messages. But if the circuit is expanded over the time, like in the 2G, we used to have this, but now it is totally expanded like by using the technology, even when first it is the from the very first circuit, it has transmitted into general packet radio services or any enhanced data rates, etc. So it has evolved into many cases. And what are the uses? So there are many uses for using this GSM because to maintain a link between the receiver and the transmitter by maintaining communication is utmost important. Also, it ensures the security of communication without involving into third party. We all see that the messages are end-to-end encrypted so that we cannot have any other, we can only the sender and receiver can read those messages. These two are the main two advantages of this GSM.
Kanchana, please check the issue. There is a lot of network issue. Are you able to
Hello,
hear
ma'am.
me? Yeah, actually, I cannot hear you right now. Your voice is lagging too much.
Hello, ma'am.
Please,
Yeah, ma'am. Am I audible?
for now you are audible, but in between your voice is lagging too much. So please see the network if it is working fine or not. Hello, Kanchana, are you able to hear me? Kanchana?
Hello.
Yeah,
Hello,
you are
ma'am.
not, yes, you are not audible to me. Right now I can hear you, but are you speaking something? You are not audible.
Hello, ma'am.
Yes, yes, I am hearing you, but you are not audible properly.
Yeah, ma'am. I think it would be fine from now, ma'am. I have, I'm using different connection now. Is it okay?
Okay, please see.
Shall I start from the beginning,
You have
ma'am?
what? Are you saying something? Hello.
Shall I start from the beginning, ma'am?
No, no, from where I
Hello.
guess, yes, are you able to hear me?
Yeah, ma'am. Yeah.
Yeah, so I can see the uses like uses one para. From there itself, we can continue.
Okay. Okay. So we can go through with the uses of GSM. So we have mainly two uses. One is to maintain the connection between receiver and the transmitter because we need to send the messages or any information and maintain a communication link, which is the most important thing. And second thing is we need the
No, Kanchana, actually,
encryption
you
of
are
data.
not audible. I cannot hear you. Means your voice is breaking so much. Okay, it's not understandable what you are saying. Please see if you can resolve. Are you able to hear me? Are you there? Kanchana, are you there? Will you able to resolve the issue? If you are able to hear me, please respond. Kanchana, please let me know that are you there or will you able to resolve the issue? Because you are not audible to me and now I guess you are not visible as well. Yeah, please let me know if you could able to resolve the issue now or you have to give the presentation on the other day. or please try to rejoin. Yes, Kanchana, are you there? If you're there, please respond. Kanchana, please respond. Kanchana, I'm waiting for you. Please let me know what is your next action, what you are going to do, whether you will give your presentation or what. Actually, we don't have any more interns. We have only Kanchana in this presentation section. So we will wait um, for her whether if she able to resolve the issue or not. Otherwise, we will see what we will do next. Let's wait if she could able to join and restart the presentation. She has left the meet. Let's wait if she could able to resolve the issue and join again to give presentation. So let's see.
I'm audible, ma'am.
Yes, you are audible.
Okay. I'm so sorry, ma'am. I
Uh,
don't know. It's really
no problem, but try to sit with proper internet connection because internet is also one of the important factor other than presentation, right?
Okay, ma'am. I have actually maintained everything proper, ma'am. I don't know what happened suddenly. Actually, it's not because of internet, ma'am. My laptop has stuck. I was seeing that my video is not moving forward along with me. It's just being stuck since where I've stopped. So that's the issue. Try to
Okay.
resolve it. Please try to understand. Yes. So there are two methods to connect the GSM to the Arduino board. The first method is by connecting without any software serial library. That is, we need to connect the RX pin of the Arduino to the TX pin of the GSM module and the TX pin of the Arduino to the RX pin of the Arduino GSM. So two Arduino pins are connected to the two GSM pins, where one of those RX pins is connected to TX and one of the TX pins are connected to the RX pin. Now the third connection is very simple. Both the grounds has to be connected. So what we need to do is we need to connect uh, both the pins in similar way. Like RX, TX are configured and the ground pins are synchronized. Then all set to go. And one more thing is we need to load different programs here. For example, if we have one application, we need to program in such a way that that application gets completed. If we need to apply another project on the same circuit, we need to load it into another program. So it will be not feasible for a projects in which we need to, if we need to do projects in a faster manner, like we need to change the project every day or we need to make the application different every day, we need to always change the programs, we need to load different kind of libraries into it. But if we use the second method, it will be easy for us to have different connections on the, like to have different kind of programs on the single board. For example, it would be having PWM pins, in which pulse width modulation pins, and the which will be some 10 to like around that. And the pins they have chosen is 9 and 10. So those are PWM enabled pins. So that in which directly we can enable the serial library. So it is an Arduino library we can see in the regular Arduino program, in which that when we write a code or we when we write a command to send or receive a message, it will automatically function and the library replicate the hardware functions also, and it handles the task of serial communication directly without any another program involved. See, if this is the command for sending the SMS. This AT plus CMGS is the inbuilt command, like it's a default command to send an SMS. And what is the SMS we need to send should be entered here. And this is the mobile number input to which mobile we need to send, to which number we need to send should be entered here. And the country code, for example, zero like plus 91 or plus double zero one. So the country code has to be inserted here. So the message will be displayed. The message will be sent in this way. So what if we need to receive the message from the Arduino board? Typing it with GSM module. Similarly, AT plus ENMI is the basic command default in which we need to enter to make the system understand that it's going to receive a command. Similarly, double two triple zero are the binary code. Like it's the code in which we can uh, send the data, like send the information that you are receiving. You are about to receive a data. And that actually we need to write a command to receive live SMS. For example, what are the kind of SMS we are receiving will be displayed. Networking protocol is Modbus. Modbus is one of the most, it is also a traditional mode of communication protocol in which it will be enabled for the devices in which already a device is connected. For example, we can say if a device is already connected to a system, it is working. If the device needs to be sent the data to the another device which is connected on the same system. For example, let's go automation system. We have different sensors working there. If one sensor is having the receiving the data and another sensor is also needs to receive data, means the sensor which is already receiving the data will transfer the data to the sensor which needs to receive the data. So the communication will be happen between the device to device without any interference of the main source data transmission. So this can be this stands examples such as humidity sensor, pressure sensor, or by computing with a programmable logical controllers, etc. So what are the uses of these device means? It is simple. Technicality is also less, not much into not much circuitry is involved, and it can be integrated easily with any other devices because to communicate with other devices and to configure with the Arduino board or any other microcontroller, it can be easily integrated or it can be easily, it has an easy way to communicate, and it has its own protocol so that we can rely on it like without any doubt. And how it operates. So first, Modbus operates in like it will just send the data to the device in which message is present. Suppose if we need a message to be sent, the peripheral which needs to be receive the data, the peripheral which needs to be receiving data will be functional, and obviously there are serial lines. So whenever the transmitter and receiver are in the serial communication port, the transmission will be done from the transmitter to receiver with a serial mode of communication. So there are no any interrupts present in the internal memory or any internal data transfer options. So it follows a simple structure to do that. First is device address. So what is the device address will be inserted into the transmitter. So transmitter will get the device address of the receiver to which it has to send the data. And function code, it will obviously have a code, function code, in which all the functions, all the libraries are involved. So in which the data can be easily transferred by the code itself. And the data means whenever the data is transmitted through the code, the data will be sent to the receiver. And also it's an error. There is an error check option here. So whenever the data is sent, we can we can check if there is any error by having an acknowledgement option. So whenever the receiver is getting data, it acknowledges back to the transmitter that I have received the total data. So we can use any of the options such as LEDs or any other blinking circles or alarms to make sure that the receiver is acknowledging the transmitter that it has received the data totally. So how we should interface this Modbus with Arduino means Arduino board used here will be RS485, and the Modbus used will be any of the like MKR 485 sheets or any. We can use this MKR board to build any of the Modbus compatible device. As we have already said, there is one sensor can be one controller can be used to transmit the data to other controllers. We can use this MKR board to make any other MKR feasible devices like MKR compatible devices. So if any device is compatible to operate like an Modbus, we can use that device also to make a connection with Arduino. So it has a similar like device address, function code, register, and register count are the main required parameters we need to consider, because in this if the parameters are okay, we can just proceed with the data transmission. So there is an example code here. Firstly, what we need to do is we need to serial print the data. If it reads to read the voltage, for example, the command we are giving is to read the voltage. If it is reading the voltage, it will just respond like by blinking an LED or something else. But if it is not reading the voltage, it will just reply that the operation was failed. Similarly, it will read from buffer. So whatever the buffer happened and whatever the issues happened, it will read it and it will display it on the like it will give us acknowledgement regarding that way also. So if it is giving the proper output, if it is getting the proper output, it will give. Or else if it is not getting the proper output, means it will read the issue from the buffer. So finally, we can resolve the issue by using by getting the input from the commands also. So the last networking protocol was Ethernet. So we all know Wi-Fi is the wireless protocol. We are using it every day, like everywhere we go. But Ethernet is a wired computer networking technology. In this, it is commonly used as LAN, MAN, WAN, etc. But it is a most traditional method in which it used to be there are to be connections made to devices we are using also. So for whatever the devices we are using for system, like for laptop or desktop, etc., we need to connect to the ports of the computer, PC, or any laptop from the LAN wire. So the two ends of the LAN wire have to be connected. One is to the device we are using, and one is to the transmitter in which we are getting the data from. So both should be connected, and the nodes, ports are should be properly connected. There should be no longer distances between this, because which leads to the data interruption and maybe signal trafficking also, any third parties or communication lines interfacing, etc. So it retains as a backward compatibility, because if we see in today's world, we are so much like technology is becoming even more faster and upgraded. We can see Wi-Fi has dominated this kind of Ethernet and any other wire technologies, because it has wireless technology also. It operates in a very faster way. But Ethernet has one of the important features that it operates more faster than the Wi-Fi. We can even see in some areas they are still using Ethernet because it is more faster, it is stable and secure. Also, it can be not like any other person cannot use our secure Wi-Fi connection or our secure internet connections. Only we can use our internet connection. That is one of the advantages. And wiring up a network can be complex, right? Some complex and costly because we need to invest on wires, we need to invest on we need to check, ensure that the ports are okay to just uh, connect the land wires to the devices. So these are the two, three disadvantages we are having in Ethernet. Also, it is it has been updated, but even in some applications, it is still used. And how the Ethernet works? Ethernet works like it will send the data into short pieces of different size frames. For example, if the big data is like, for example, if a big information is used to be is required to send, then what happens is this information will be sized into shorter pieces. Like those pieces will be called as frames. Those frames will be contain some standardized information. So for the total information will be partitioned into different frames, and that will be shared by single connection through a LAN wire. So it is important in the early days because we don't have any other options of using these kind of full duplex applications, especially we don't have any other separate channels or collisions to make even more feasible, to make even more upgraded. We don't have any other options also in the olden days. So that Ethernet is the main importantly or most popularly used uh, protocols in that days. But even still, it provides the basics, like it provides the most internet digital communications, or it integrates easily with even higher level protocols also. So it is not having that much of issues these days. So that only it is in the use even now. And how to interface Ethernet with Arduino? We need to use Ethernet Shield 2 or Ethernet Shield or Leonardo Ethernet or any other uh, W5, 500, 200, 100, any other, those kind of basic devices can be used to connect the Ethernet to the Arduino. And that library will allow the Arduino board to connect to the internet automatically when we interface or we configure that Arduino to the Ethernet shield. So it is having like serial peripheral interface communication. You can see the diagram here. So see, we can have four input means we can have master and slave here. So if the master is in operation, slave will be in rest, and if the slave is in operation, master will be in rest. So the serial clock will be provided. That means same clock will be provided in the each and every pulse, like for master and slave also. If the master is operation, the serial clock will be provided to the master. If the slave is in operation, the serial clock will be provided to the slave. If the master is receiving the input, slave is receiving the output. Similarly, if slave is providing the input, master will be receiving the output. That is mentioned here. Serial clock. MISO means master input slave output. MOSI means master output slave input. This is for SD card. So the 4 pin and 10 pins are connected to the SD card. That's for memory. So we need to store the information, or we need to like what are the previous applications, what are the outputs in the previous data, previous operation we got will be stored in that. And what are all the libraries we have? So if we have some libraries to get this data out to transmit it, we need some libraries. For example, these are the important libraries to like to for making some algorithms. We need to libraries like communication, data progressing, data storage, display, sensor, signal input output, timing, device controls, etc. are the basic libraries we use. So there are some official Arduino libraries also. We can also get them websites like that. For servo motors or stepper motors, there will be different libraries. So whenever we need to apply for different projects, we just have to inbuild like import the library from the data, like we import that library from which of the languages we are using, and that can be connected to the communication ports. This also use the I2C serial peripheral interface or UART protocol. It is an unsynchronized method of protocol. So that unsynchronized method of receiving transmitting, asynchronous method of receiving transmitting can be done. So SPI means it is a serial peripheral interface, or it can be having two-wire interface also for sending one wire is for sending and another wire is for receiving. Similarly, as we have observed earlier that software serial communication can be done, which has similar to the Modbus, like by having digital connections of input and output pins. So next is communication protocols. First is HTTP. What is HTTP? It is a hypertext transfer protocol. It is the basic use, like the basic browser we are using every day. Right? It is the backbone, like which is having behind the browser, which website is working, like which is there are some set of rules which are working under HTTP. For example, to transfer the files, for example, to display any text, to images, sounds. We all have like CSS, JavaScript, HTML, R, and another like in the front end and both in the back end. We have that kind of application. But HTTP is the protocol in which to transfer the data to present on the screen is the HTTP. Like it's a protocol which is called HTTP, in which we can use. Suppose if we ask something to the browser, so when we send the request for a resource we need, it will just load a web page, and the server sends the request to the client back to fulfill our request. For example, if we ask something to the web server and the server loads the web page, so whatever the data we have asked, it will be given back to us to fulfill our request. This is the very basic process we use every day is the HTTP. And next is MQTT. MQTT is a lightweight publish subscribe machine. It's a machine network protocol in which we can have for example we can have a one is publisher, another one is subscriber. So if the publisher is sending messages, the subscriber can receive the messages. For example, we can have home automation systems or water tanks. Or see if the water tank is over the limit, if it is crossed the limit means it will automatically send a message to the subscriber that it has been over. Or for example, we can have
Kanchana, are you there? Kanchana? Kanchana, are you there?